Hello everyone, I am Abdullah Abuolaim and I'm going to present our paper about improving single image defocus deblurring and how dual pixel images help you through multitask learning framework. This work is done with Mahmoud Afifi and Michael Brown. And before I start, note that you can access the GitHub page for the code and dataset by scanning the QR code here. First, let me describe dual pixel or DP sensor. A DP sensor, which is common in smartphone cameras, provides two photodiodes at each pixel location as shown here. By creating images from the left and right photodiodes, we obtain two sub-aperture views at single image capture. These views exhibit a difference that is correlated to the amount of defocus blur. DP sensors are used for autofocus, but last year, myself and Michael demonstrated that DP data can provide useful cues for defocus deblurring in a data-driven approach. In our prior work, we used a data-driven approach based on DP training data to perform defocus deblurring. The work required paired data for training, namely two blurred left-right DP views and a corresponding single sharp image. DP data was also required at inference time. The challenge in this prior work was that collecting this paired training data was a tedious process that required a careful setup. Another challenge is that while many cameras use DP sensors, currently only two models provide access to the DP data. However, we still want to perform defocus deblur for cameras that do not provide access to DP data. So the questions we sought to answer are: can we reduce the reliance on paired and hard to collect data? And can we design a deblurring method that works on a single image input at inference time when the DP data is not accessible? To address this question, we propose our multitask network that has single encoder and multiple decoders. Our network is a single input model that takes the blurry image and estimates the two DP views and the corresponding sharp image in a multitask framework and through three decoder branches. The main idea of this proposed multitask framework is to first train for the DP view estimation task using the DP decoders and DP data. The nice thing about this type of training is that it doesn't require paired data or a careful capturing procedure, as all we need is unpaired DP data that can be captured in the wild with no constraints. For this first training stage, we were able to collect thousands of training images. In the second stage, we trained for the other task of defocus deblurring to estimate the sharper image through the deblurring decoder branch. In this second stage, we trained for the two tasks jointly. As for the inference time, our multitask network doesn't require the DP data to be available at inference time, which makes it able to deblur for a single input image. Not only that, it also estimates the DP views of the single image input. For the quantitative results, we compare with other single image defocus deblurring methods, and our method achieves the best results for all metrics, including the signal processing metrics and the perceptual metric Naturalness Image Quality Evaluator (NIQE). We also achieve on-par results with other methods that require dual pixel data to be available at inference time. Furthermore, our appellation study demonstrates that each task is useful to the other in our multitask framework. In particular, predicting the DP views help the deblurring branch to get better results and vice versa. As I mentioned earlier, we train our multitask network using one defocus disparity direction, so the predicted views are always left-right dual pixel views. Then the question is, what will happen if we rotate the input image and feed it to the network? Let's see what will happen. We can get multiple sub-aperture views synthesized from each rotated input image, and by alternating the synthesized views, we can get this nice image motion effect or NIMAT effect. Here's some more result visualization of the NIMAT effect of data from Canon camera, and this nice effect is all generated from a single input image. All our training data is captured using a Canon camera, but still, our multitask model is able to generalize for other cameras and generate the NIMAT effect for an image captured by a Nikon camera. To summarize, we introduced a multitask framework for dual pixel view estimation task and a single image defocus deblurring. We also demonstrated that the two tasks are beneficial for each other, and the DP view estimation task helped us to reduce the reliance on paired data that require tedious capturing procedure. This framework is also useful for single image defocus deblurring when the dual pixel data is not accessible at inference time. At the end, we got a free byproduct, nice image motion effect called NIMAT effect through synthesizing multiple sub-aperture views from a single input image. Thanks for watching this video. You can scan the QR code here to access the GitHub page for the code and dataset. You can also scan the QR code on the right to check our extension of this work. In this extension, we introduced a modification on the blur synthesis procedure in the smartphone's portrait mode that gives you a nice bokeh photo plus our new NIMAT effect. Thank you.